Members of the media, welcome to this extraordinary event hosted by Deep Dive Dubai. My name is Amy Kitchingman and I am your host. It's an absolute pleasure to be here with you for this extraordinary event. So we are here at the wonderful Deep Dive Dubai, an underwater haven for both novice and professional divers alike. And it stands as the epitome of diving excellence and is renowned as one of the world's most unique diving experiences, where it's not just a chance to explore the depths, but also a gateway for people to begin, enhance, and develop a profound underwater connection. And today at Deep Dive Dubai, we are thrilled to introduce you to the OceanOneK robot, an exceptional piece of technology that is set to redefine the way that we explore the depths of the ocean. Now, this robot is not your ordinary underwater machine. It possesses a rare ability to not only perceive its surroundings, but also interact with objects underwater. So what sets OceanOneK apart from all other underwater robots that are available on the global stage? It has the capability to establish and connect with humans. It's not just a tool, it's a partner on our journey to uncover the mysteries underwater. So today, right here at Deep Dive Dubai, we have a unique opportunity to witness the OceanOneK robot and for it to exhibit its diverse capabilities. It's a moment that marks a pivotal advancement in underwater technology, showcasing the immense potential for innovation and immersive experiences in the field of underwater exploration. So as we prepare to witness this extraordinary display, let's celebrate the spirit of discovery, the wonders of the deep, and the limitless possibilities that the OceanOneK robot represents. So join us in this historic moment as we embark on a new era of underwater exploration right here at Deep Dive Dubai. Now, the masterminds behind this groundbreaking project are Professor Oussama and his team from Stanford University, who are here with us today. And we're going to hear from Professor Oussama shortly. But now to explain a little bit more about the relationship between Deep Dive Dubai and OceanOneK, I'd like to welcome to the stage the director of Deep Dive Dubai, Mr. Jared Jablonski.
Thank you very much.
Thank you.
Good morning, all. Very nice to have you here. And thank you for taking time out of your busy schedules to join us this morning. And we're very excited to show you some really neat technological innovations. And I'm not going to talk very long because I know you didn't come here to listen to me. But as the director of Deep Dive, I see a lot of parallels between what we're doing here today and the work that's really inspired me throughout my lifetime. And the bold vision and future possibilities that really inspired the creation of Deep Dive Dubai and I think helped to drive the city of Dubai, this innovative spirit really resides not only in our facilities here and the operations that we try to manage, but also in the inspirational and forward-thinking developments that are presented with Ocean One. And I've dedicated my life to underwater exploration. My passion has always been deep, long-range technical dives. So I do, cave dives that last for 10, 12, 14 hours, 30 hours underwater, diving in the 100 to 200 meter range. All of those sound, interesting as a human, but they're quite boring, and they barely scratch the surface of the amazing vistas that can be seen in the deep ocean and the outer space realms. And for me, here at Deep Dive, we've really spent all of our energies trying to curate an experience for visitors to make a connection to the underwater world, to experience from very beginning novices who first come to their first underwater experience, through technical divers and free divers who are interested in exploring and expanding their limits. And so this facility is dedicated to that activity, and learning in that way allows us to go out and be more capable underwater explorers. Yet when I look at the things that the robot might be capable of doing, I feel rather jealous. I have to say, despite my years of diving accomplishment, I will be very jealous of its future accomplishments. As I told Oussama earlier, the professor has built a fabulous invention. And I will be jealous, but what I love most about what Professor Oussama and his team have been able to accomplish is the care and forethought for the human experience as well. So closing that gap between the machine and human interface, because there will be places in outer space and deep sea that we could never go as humans no matter how hard we tried. And Dr. Oussama is changing that world by allowing us to really live the environment and to feel it and interact with it in a very dynamic way. I'd like to make sure everybody is aware of the haptic feedback system that we have as a side note, because it's easy to miss, and normally when somebody says try this out, you're like, oh, whatever. But then when you do try it and feel that physical interconnection, you'll start to understand a bit about what Professor Oussama and his team have accomplished here. So it's with great pride that I bring Professor Oussama up. He is not only an accomplished, amazing roboticist and professor at Stanford, but he is a genuinely kind and warm human being and a pleasure to be around. And only someone such as yourself could lead a team that is so all-encompassing and dedicated to really allowing humans to experience something that could not otherwise experience. So please, Dr. Oussama, come forward. Everyone, welcome Professor Oussama Khatib.
Thank you. Thank you.
Do you want
Yes.
the mic?
I think I have this mic. Can you hear me? Yeah, perfect. Well, it is a really great pleasure to be here at Deep Dive. Some years ago, His Excellency Omar from AI called me and said, you have to come to Deep Dive. There is something amazing, you have to. And I came, and he was together with you, Gerard, and you said, you have to bring this robot here. And it was really incredible. I mean, we've been in the sea, in the oceans with the robot. It's very hard to control the environment there. But having an environment as rich, having a playground for the robot per se, was something really, really amazing. So it took us 2 years to bring the robot, but finally we are here, and you are going to see some of the tasks. We cannot show you everything because we don't have enough time. We recorded some part of those images. But before we start, I wanted you to also see what we are really doing with robotics. Robotics is not only about underwater or about medical robotics. Robotics is about many applications that brings the human and the machine to work together. So the first time this robot went to an aquarium was in Genoa, but that was virtually. It wasn't really the robot there. It was moving, looking for a way to go in the water, and we had to come all the way to Dubai to Deep Dive to do it. But before Deep Dive, we were in the Mediterranean between Marseille and Corsica, diving on a boat, going down from 40 meters to 120 meters to 300 meters to 500 meters, finally to almost 1,000 meters. Building a robot that can go in the water under human control to 1,000 meters is a big challenge. And believe me, it is not something that we brought up easily, designed simply. We started with a more modest goal of going to 100 meters. But again, what are we doing? We're building a robot, and this robot is going to work in unstructured, difficult environment. It cannot be completely autonomous. It has a huge amount of autonomy, but it doesn't have the cognitive autonomy of a human, the experience. So this is another task, the same task actually, where we are doing ultrasound imaging on a human. Here we are using a phantom, using this connection between the expert and the machine. So when it comes to OceanOneK, we call it K, there was an OceanOneK before that. And that OceanOneK was designed and deployed in the Mediterranean in 2016. So why we designed another robot. I mean, there are so many underwater robots. What is different here? Well, most robots are able to see, perceive, and scan, but they cannot do, they cannot interact, and they cannot reflect what they are feeling to the human. The diver here is feeling what the robot is doing. In fact, if you come to my lab, you can have this simulation and you can experiment yourself an exploration in the water in a virtual environment. So, virtual environment is not enough. We have to build the robot, we build it, we get it in the water, 1.5 meters in the pool at Stanford. And you know, when the robot is in the pool, a lot of students are sitting by the pool watching the robot, and some of them will jump and swim with the robot. And that was the preparation for the expedition, the first expedition ever of a robot that is your avatar in the water. This is a true avatar because the robot has your eyes and your hands in the water. So your hands are through this device we call haptic device. And proudly I say this haptic device was designed by one of my former PhD students who's here with us, who will also show you some of the interaction with haptics, which is very, very critical to interact and touch and do things in the environment. Actually, the haptics saved this robot. It got caught between these two cannons, and the haptic device let us push against the cannon to free the robot. You can see how Hannah, my student, was praying for God to free the robot, and finally we were able to free it with the haptic device, recover, and bring back a Catalan vase from 1664. So this was a big event in France, in fact, in April 30th, 2016, and it gave us the sense that, yes, we have to continue and go further. And the press conference and the people, I mean, the archaeologists, there was an archaeologist conference, they said since Jacques Cousteau, we didn't have a technology like this to help us go in the sea. So, not only the sea, the electrical grid. With DEWA here in Dubai, we are working on doing the same thing, to remove human from dangerous locations and allow human to interact with those robots remotely. Well, this is much easier because these are much simpler robots. Having a robot in the water, in the current, and in like flying robot, this is very hard. The stability of the robot is much more challenging. During COVID, we conceived a system where instead of having to wear all these gears to go inside the room with the patient, we can connect a haptic device and interface for the physician to perform those tasks. So here is how it's working. You move the haptic device, you are guiding, you are feeling. This is very important for the doctor. The doctor actually is teaching the robot how to do it. And the doctor is looking at different high density areas and performing motions, and you know what? The robot can do it again on its own much better by optimizing those motions, simplifying, and maybe speeding up the video. Yes, now this is the idea, human connected to machines in many domains, in construction, many, many different areas where you can do the work remotely without exposing workers to the dangerous fume of painting. For offshore platforms, we can replace the human work with those dials. Actually, recently, again, the design of those haptic devices was modified to allow them to go to space. And in space, we were able to connect a haptic connection of an astronaut to control a robot on the ground at DLR. So what is about OceanOne? OceanOneK is taking this robot OceanOne much, 10 times deeper. 10 times deeper, it means like, imagine this atmosphere here, you're going to have 100 times the pressure of this atmosphere. And that means this robot will become like an elephant. It couldn't enter in this room because you need much more weight and compression to lift the robot. The robot has always to be buoyant. So we discover new material. This is hollow glass microscope spheres that allow us to keep the volume almost like a human diver. And you can see the design allow us to almost have the same size. And here we are showing how the robot can now start to make use of tools. This camera, we used it to go inside enclosures inside the boat where the robot cannot go. The robot is able to interact and collaborate with the human and support the human in many different ways. So Gerald, don't worry, we will carry the oxygen for you when you go in the caves. There will be much more time for you to explore. So anyway, we finished OceanOneK and we took it to the Mediterranean. And this is the vessel that we've been using. I'm sorry, I think, okay. Oh, it doesn't want to move. Well, that's fine. Anyway, the robot arrived on the vessel, and this is the control room. It's very similar to that setting, and we started going to the P-38, which is a combat aircraft from World War II, a submarine. Then we went to Corsica. We went to an area where you have a Roman boat from 2000 years with completely disappearing except the cargo that is there. And we were collecting a lot of artifacts from that site. Beautiful cups. I mean, the archaeologists were amazed because this is so fragile and so difficult to find, and they were studying this, but they never had their hands on one. This is beautiful oil lamps decorated with palm. And if you turn it, you can have the address, and if you need to order a few, they can go through Amazon and you have order. Now, one thing that was amazing also for the marine biologist was that we found some pieces of wood, and now tracing the wood, we know where this boat came from. And there were a lot of articles written about the marine biology associated with it. Well, for lunch, there are a lot of shrimps. I cannot believe how deep they go. Now, then we went further down, and this is the Crispy, an Italian boat. This Italian boat is incredibly like a new house for life. We started by placing this marker, and placing the marker was really incredible because you are placing the marker on the rail, and you see the marker. This boat was never touched by a human, and you have in front of you the person who touched it and placed this marker that is allowing us now to go and scan and then reconstruct the 3D and do something that wasn't possible before. So a lot of things to tell you, but I'm going to move now to show you very soon, shortly, the robot in action. The last task that we wanted to do was to take the robot to some location where we can test whether the robot will sustain the pressure of 1,000 meters. And we went to Cannes, not for the film festival, but we went to Cannes because in front of Cannes you have the Himalayas inverted. You can go deep, deep, deep. So we first started with this boat. You can see we are filming inside, and it was amazing. We were able to film and get everything. And when we came back, Wesley, I asked him, can we see the video? He said, oh my God, we forgot to start the video. So we don't know what is inside. We have to go back. Then the robot started to move down 750 meters, 800 meters. And believe me, the same controller that we use for 1 meter, was used for 1,000 meters. And this is what is beautiful about how you balance your robot, make it, now the robot is diving, and you see it's carrying a message. Would you like to know what is the message? Yeah, everyone is saying yes.
Yes.
Okay, I'm going to try to read it. A robot's first touch of the deep sea floor, a vast world for human to explore, and I said we won the Palme d'Or. With the crew that was amazed about our accomplishment, I mean, in those missions, you have a huge number of crews. Like in here, we have a lot of people involved in making this happen. Thank you very much for your attention to this screen, and now we're going to move to the other side. Thank you. Thank you.
Come on up to the white shades there, because you can get a little better view.
So here we have the ocean. Which is going to show robot interaction. So you can see on the screen how the robot can interact with divers, also using hand gestures and signals.
So, do I have the microphone? Yes. Yeah, good. On the screen you can see interaction that is non-contact interaction. So the robot is perceiving the signs and interacting with the divers. The robot has mobility in the head, which is really important in manipulation because you really need to see your hand with respect to the environment. And this is what allows the robot to move the head and interact in different ways. So we're going to see a number of coordination between hands, eyes. Hand-eye coordination is a major project that was launched at Stanford, in fact, in the AI lab in the 60s. And Professor McCarthy at the time launched this hand-eye challenge. And we are now past even the hand-eye because we are coordinating body, whole body, eye coordination together with haptic interaction. So now we are going to perform a task, a very common task of maintenance with structures built by human underwater. There is a hose And I'm going to try to remove it with assisting a diver who is holding the frame. So we'll do it with the right hand, probably. And move to the left a little bit so I can see, okay? And give me control, please.
Also at this point, I just want to say, if anybody wants to use the 3D glasses, I think we have some glasses there at the side, so you can have the 3D experience through the screen, which Professor Oussama is also looking through.
So now I'm going to grasp it, and I'm going to pull it out. Wow, that was fast. Well, thank you, OceanOne. So this was an easy task where the diver now is going to take we're going to give it back to the diver, and we will go for a more challenging task. Okay, okay, it's floating. All right, why don't you move it back and let's go to this table. I see a lot of things on the table. I think there are too many objects. Which one we're going to take? I don't know. All right, let's go down and see what we can take out, clean that table. Okay.
That we're going to see the robot do now is artifact collection. Actually, yesterday when I had a meeting with Professor, it was called Going Shopping, which I was devastated about because I thought, oh no, the robots are taking shopping away from us now. But it is actually the collection of artifacts. So we're going to see now the robot collect some of these objects from a table and then place them in the basket before ascending to the surface. So this demonstrates the way that the robot can collect certain artifacts and then bring them to the surface.
Yeah, that's very good. Excellent. Make sure the height is down. Someone is reading the newspaper. I don't know if we can read the news. So you don't see it, but I'm seeing in 3D, so I can see depth. And depth is very important in manipulation. So right now I'm approaching the table, I'm just focusing on that right hand. And the right hand is, could you move the head to the right a little bit? Thank you. Okay, slowly we are going to go to the cup. So almost over the table. And I'm orienting the hands to grasp it. You see, in the water, when you move, it's very difficult because you are moving also water. Yeah, I need to go to the right a little bit. Yeah, right. Okay, and yeah, I can close it. All right, it is in the hand. Now we can place it maybe in the box, in the basket down here. So go to the basket, please. Let's move to the basket. So this task requires really depth because from here you cannot tell where it is, but I can see we are still far away. We have to move forward to the basket. We are too low. Could you move the head up, please? So Wesley here is helping me with looking in 3D to see where we are with respect to the basket. And we are moving closer. Could you move forward, please, Adrian? I can get over the basket, Adrian. About right, the head to the right. Yeah, that's perfect. Move forward now. So I'm moving forward. I'm at the maximum. Can you move the robot body? Yeah, please. Move the mover. Can you move the body because it's stuck? Yeah, it's stuck by something. I cannot move it forward. What is it? Okay, now it's moving again. maybe some thrusters was not happy or something. Okay, let's go move to the right and give me a second and I will be there. Okay, little more, and here we go. In the box. Yeah. All right, so let's go back to this side. Now, the robot is going to the basket.
Yes, so next we are going to see OceanOneK have a game of basketball. Before we do that, while they're just prepping, we're going to go to the screen again and we're just going to watch a very quick video about the birth of Ocean One. Now, this was the first version of Ocean One, and this was the robot that could go to 100 meters. Obviously, we know now that OceanOneK can go to 1,000 meters. So this is the sister robot and the original robot.
Cannot give me like this? Oh, yeah. Okay, we're going to take the basket, actually. Apparently, we need to take it somewhere else. So slowly, slowly. It's yeah, perfect. Like a bit more.
So now the robot is picking up the basket of the artifacts that it has just collected, and we're going to actually see the robot ascend to the surface, carrying the basket.
It is heavy. Oh my God. It's really heavy. You see the robot is tilted forward. Okay, let's put it on the table. Which table we can put it? Maybe, can you turn? I put it on. Go forward. Okay. Do you want to put it on the table? Very good. Go to the table. You see the current was pushing the, oh, no, you missed the table. Okay, so let's put it back on the ground. And I'm going to release it and go up. All right, perfect. He's happy. You can see the robot is waving. All right, so let's take a look at the screen now, and while we are setting the next position for the robot. So over here, you can, well, could you run the video, please? Yeah. So this video is showing the robot playing basketball. I'm not sure if we call it playing basketball, but you're going to see the robot able to bring the basket inside, the ball inside the basket. Bravo! We're not going to do it again because it is like in the back, so this is a better angle to see it. And in fact, in the water, the problem is you are always fighting with the water. When you move an object, in fact, the weight of the object is 1.4 times its real weight in the air. All right, second time. Could you show the video of the robot in the sea, please?
In the sea?
Yeah, and then we can go back to this one. Yeah, that's perfect. So this is the assembly of the robot during COVID. This is what we were doing, testing the robot with different devices, and then we took the robot to the Mediterranean. And most of the students who were there were on the boat, working, repairing, fixing, deploying the robot to the water. And operating in the water is not easy, but what is amazing every time is that when you touch an object, you feel it. It is like your hands in the water without getting wet, basically. So this is the robot in the area where we recover the oil lamp. and bringing the oil lamp is done through placing the oil lamps and all the objects you collect inside a container. You can see how beautiful these objects are. And the archaeologists, of course, were very happy. So now I think we are going to go to the next live demo. And the next live demo, I think, is mirroring. So, Amy, what was the next one?
Yes, so team ascent and self-awareness. So we're going to see the robot positioned between the two divers in front of an underwater mirror. And this is creating a juxtaposition between human and machine. So you can see the mirror here.
Yeah. So now the robot is looking at the mirror and it's seeing itself, and it's surprised because it sees some human swimming beneath. Wow.
It's a moment of sentience.
Yes. Yeah, actually, there is a lot of oxygen coming out from the So we are moving the head of the. Are we still looking? Huh? Yeah, it's aligned. Okay. So, yeah, we're going to do it in here. So next, I think we are going to do
Treasure hunt?
a movement of coordination. Could you please explain the task?
For the treasure hunt, it is?
No, before the treasure hunt, we're going to do synchronization between divers and
Okay.
team ascent. Yeah.
Okay, yeah. So we're going to get the robot to maneuver into a position with a team with the divers, and they're going to be able to communicate between the teams. And with these actions, we're going to feel the gap closing between machine and human as we see how they efficiently work together seamlessly.
My God, I need to get the fingers. Sorry, I have to close the hands myself because the robot is now seeing everyone closing their hands. Okay. Hold position. Stay in position.
Beginning is up.
Okay, the robot is asking the divers to go up and waving. Yeah, it is fine. It is fine. It is happening.
Earlier, like when it uses these hand motions, like I think this one was leveling up, was it? Level up, yeah. So it's communicating with its fellow divers, telling them like what to do, what the team is going to explore next, etc.
All right, and then what is after? Could we go level? Oh. Okay, level. Stop. Stop. All right, that was. Yeah. Okay, so should we succeed? Yeah. Okay. All right. Next, I think we're going to the next demonstration of the robot, and that next demonstration would require your help, right?
So if you all want to come round the observation window, because we're going to actually need your assistance. So we are going to go on a treasure hunt. Are you ready?
Go down. Huh? Yeah, fix the arm. Yeah. So while we are setting the demo, let's continue the second video, please. So the next video on the screen, can you play the video, please? Okay. So this is an area deep here, a deep dive, and the robot went to this room and explore this area. I think it's at 38 meters, and usually it's not easy to access, so we're not going to go there, but you can see what is inside. It's a very interesting space for divers to explore, and I think now Deep Dive has a guide to show this in Deep Dive. All right, when you're ready, you tell me. So this is another task where the robot is coordinating with a diver to cover a large container in which we place different objects. This is a task that requires always two divers, and in a way we are assisting again a diver to perform those tasks. You ready? Okay. So it seems like we are ready to go for the treasure hunt, and I leave it to Amy. Amy, yeah. Please help us.
So we're now going to go on a treasure hunt for treasure, obviously. So as you can see now, the diver is there in front of the treasure chest, and we are going to get a clue as to what we should be looking for so we can get the code to open up the treasure chest. So of course you can also look here on the board. So can you see what that picture is? Through the eyes of OceanOneK, can you see what it's a picture of? Looks to me like a shell. No? Can you see?
Yeah, this is like a shell, it looks like.
With a pearl inside.
All right.
So we're looking for a shell somewhere within the dive area. So has anybody seen a shell anywhere?
Well, let's ask the divers, but the divers will not speak.
Let's ask the divers.
Well, I'm going to try to go.
Or if we can see through the eyes of OceanOneK where the shell is.
Okay, keep rotating, keep rotating. Oh, look on the right, there is something. Okay, yeah, go straight, go straight.
Can anyone see it?
Huh? No, just.
I think that's something on top of the bookcase. Could it be? Let's see. Can we go closer and see if that's what it is on top of the bookshelf?
The diver is indicating, confirming that the shell is there. Okay, so now we need to go and take this shell and see what is in it. And lower and to the right. Control, I have control. I have. No, too close now and too fast. And I'm saturating now. I'm not aligned. Yeah. Yeah. Okay. I need to go to the left a little bit. Go little.
Can locate something and then go to retrieve.
This is going too fast. And too high, too high. Slowly, 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 slowly.
We're on the video.
It is not, it is up.
And we have it.
Yeah, I have it, but one finger didn't go. Okay. So if you move, if you do any sudden motion, it might drop. I hope the diver is. Could you rotate? Yeah, one finger didn't go completely inside.
Okay, so can we see?
So could you rotate to
The
see what
shell.
is inside the shell?
And there is
Just to
a
rotate,
message on the
Yeah, yeah.
pearl
What I'm saying is
written.
without
Can
the-
anybody recognize what that is?
With
Let's see who paid attention in maths
go,
class.
go. Oh,
Does anybody
okay.
know what that symbol is?
We need light on it. Okay. Rotate it towards us. Toward us. Yeah, I know. It takes time. And forward. Forward, come to the screen and hit the screen with it.
I would say, do we have?
So,
Yes, well done. Pi.
so we are looking for a 4-number code.
So we're looking for a 4-number code. What are the first 4 numbers of pi?
311.
3.
I need to check. I didn't pay attention in maths.
Okay.
Yes, that's correct.
Okay, I'm going to hand. Okay, thank you. Wonderful. So now we know the code, and we're going down.
Okay. So now
To
we're going to
get the
go
code.
put the code in the treasure chest. Let's see.
Okay,
Hopefully,
your
it's
arm,
the right
your arm
code.
is. Huh? Try to fix the arm quickly. If you can.
So divers, the code is 3141 according to the login. So go and see if you can unlock the treasure chest.
Okay, can you drop one arm? Why don't you, we have a little problem with the left arm. Could you drop it? Yeah, fix it, yeah. Yeah. All right. We're going to wait here before going to just fix the... So there is a cable that is preventing the joint of the shoulder to move, and we need to fix it. Go ahead. I don't know if that happens to you, but the robot's shoulder is hurting and he's trying to move. And the reason it's hurting, there is a cable inside that is blocking the shoulder, and we discovered it yesterday, but we couldn't fix it immediately. Okay.
So we succeeded in opening up the treasure chest.
Okay, let's go. So now I'm seeing it in 3D. He's very close, and someone is blocking my way.
The camera on the treasure and the treasure that the robot can look
All right. Okay, now we have the treasure. Let's have a closer look at treasure. Yeah, please rotate and come in front of the camera. Can you level the robot? Go up a little. Look at the treasure with your height. Move the head to the treasure. Move the head to move the head lower, lower, and to the right. That's enough. Let's move. Yay!
OceanOneK looks very pleased with themselves, having a little dance.
Yeah, I think the robot is quite happy now.
I thought we had an agreement that they were going to bring me the gold necklace back.
Okay, I'm going to give this piece to the diver. All right, move back. Yeah.
So maybe if you want to dance with OceanOneK and they can copy your dance movements. So if you want to give like a wave or...
Chest.
Wait, yeah. Move to the right, move to the left. You move and move opposite. Move to the right. Move. Could you rotate 90 degrees and the head, put in overhead to keep the head towards the screen. Move the body.
And if you want to look to the screen on the left, you can also see the view from OceanOneK, which is all of us.
Move forward, more forward. Yeah, very good.
You can wait.
All right. Oh my God, it's going to come and hug someone. I never saw the robot so happy. Okay, so please go ahead and take photos with the robot if you would like. You can have selfies and we can leave it there. Could you close the hands, please? Keep the hands closed.
If any of you have not had the chance to try the haptic feedback to feel
Close
what the
it.
robot feels like, there's a station right over here.
And of course, if you have any
It's
questions,
drifting.
don't feel shy to ask Jared or
bring it.
Professor Oussama. They're available for any questions or queries that you might have. Thank you very much for joining us all today, and also don't be shy, stay for some refreshments as well, and of course ask any members of the team about any questions that you might have. Thank you so much,
second
and I
take
wish you
was
a safe
good.
trip home.
Good practice, right? After that.
No, he woke up. I mean, he was really not awake, but it is okay. It is okay.
He's not awake.
No, because really the coordination is very hard. Without him awake, it is out of concentration, but everything
Yeah, for sure.
wonderful.
All good. See, I told you it's going to be a good event. So there would be the social media team. They would want one footage with the robot in the background with you. So that once they clear up glitches, and then few opportunities for talking for Jared and for you. So we'll have the chair set up now. And then,
Are you uncomfortable? Would you mind doing some Arabic? Would you be uncomfortable with that, or you think one of the stations is asking?
I can
Try a bit. I mean,
do a mix. Yeah, I can do a mix of things. It's I mean, the technical expressions are always in the different. Yeah, but
just
I
use
can
English
say
for this.
a few words. Yeah, I can few words Arabic.
Yeah, I said this, people always tell me speak in Arabic, and I say I can't, for my